Hello gang, today's lesson is going to be about the difference between mass and weight. We're all pretty familiar with what weight is. You've seen it on TV and commercials, online, on Twitter, about people needing to lose weight or gain weight and how weight affects how we feel about ourselves. But what I'm going to teach you is that it's not really your weight you need to watch, it's your mass. Let's talk about what mass really is. Mass is the measurement of the amount of matter an object contains. In other words, it's how much stuff something has. It's represented by the variable m and is measured in the unit of kilograms. It only depends on the amount of matter an object contains, and no matter where you go, you'll have the same mass. Weight, however, is a measurement of the force of gravity acting on an object. It is represented by the variable Fg and is measured in the units of newtons. When we're not using the metric system, you're familiar with measuring weight in pounds. If we go back to mass, if we're not using the metric system, mass is actually measured in slugs, but nobody's ever used that before. So weight, it depends on the object's mass and the gravitational field acting on it. So when you go to the moon, you actually change your weight, but your mass will stay the same. Here's an example. Meet Patrick the cat. Patrick the cat spends a lot of time sleeping and very little time running around and exercising. Therefore, Patrick has a lot of mass. He's got a lot of stuff, especially in this middle area. If Patrick were to go to the moon, Patrick would still have the same amount of mass. This middle section, it would not get any smaller. However, we would say that his weight would change. Why is that? Well, the moon has a smaller gravitational field than the Earth does, and because of that, Patrick will actually weigh less. So, a really quick way to lose some weight would just be to travel to the moon. Again, unfortunately, he has the same amount of mass, so this midsection is not going to get any smaller. In the lab activity that you completed, you created a graph of weight versus mass. You can see here that mass and weight have a direct relationship. As the mass increases, so did the weight of the object. The slope can tell us the relationship between mass and weight. We can calculate the slope by using the formula rise over run. So in this problem, if we started at 0, we can see that we went up to about 49 newtons, and we ran 5 kilograms. So to find the slope, we would do 49 divided by 5. In this case, the slope is 9.8 newtons per kilogram, or in other words, 9.8 meters per second squared. This number should sound familiar to you. 9.8 meters per second squared is the acceleration rate of that on Earth. That means that when you jump up, you are accelerating back towards Earth at a rate of 9.8 meters per second every second. We call 9.8 meters per second squared, or in other words, the acceleration due to gravity, little g.